Hi, Stuart here. Today we're going to talk about cloud data and about cloud data and data governance, and try to give you an idea of some of the areas that ought to be of concern. The problem that we often see when we're working with clients that are putting enterprise systems into the cloud is, for whatever reason, they don't treat those systems with the same respect that they would have treated the data and data governance and other policies and procedures if they were building those things in their own data centers. And that has some pretty significant consequences, all of them bad. And just because the cloud may offer different capabilities in different methodologies for working with data, different tools, doesn't mean that the core of good data practices isn't exactly the same. In fact, if anything, data in the cloud should be treated with more respect, because once the data is in the cloud, your enterprise has more opportunities to leverage it. So we're going to talk about some data governance issues at kind of a high level in this video. And I'm not going to drill down into, for example, how to use this tool in this cloud the best way possible. There's lots of documentation on that. And instead, I'm going to focus on the important things in data and data governance and data best practices in general. So let's get started. Domain-driven design was a concept that was put together by Eric Evans initially. Lots of other people have added on to his work. Domain-driven design is still, even after all this time, the state of the art in visualizing systems effectively and being able to separate concerns and have clean, high cohesion, low coupling data models between subsystem components, or indeed even between systems. And so one of the things that we see happen as people go to the cloud is they tend to have a bunch of little teams and they are all working on their own thing. And for whatever reason, people don't stop and do the all-important data modeling, and from that, the domain modeling, to make sure that things that they stand up are clean. And I've never seen a successful, high-scale, critical enterprise project succeed without at least some of the elements of domain-driven design and implementation being followed. It is a recipe, if you will, a set of constraints and modeling techniques that allow you to deliver software that is maintainable, scalable, secure, etc. So if you haven't read about domain-driven design, you should. This channel is going to have a lot to say about domain-driven design in the coming months, but it's definitely worth reading the book or reading the follow-up book by Jimmy Nilsson, Applying Domain-Driven Design and Patterns. And it's an excellent place to start when you start modeling. If you don't use data-driven design based on domains, what you'll end up with is a data model that has very bad cohesion. In other words, that parts of the model that are stored within the same repository or adjacent repositories are not nicely modeled. And it makes it difficult to change. It makes it difficult to maintain because it's difficult to understand. And then you end up with a lot of concerns that are in more than one place. And we'll talk about that in a little more. So I wanted to stop and say a few words about microservices. I like microservices. I have no complaint about microservices. Microservices are an implementation choice, not a design choice. And the microservice architecture pattern enforces a certain set of rules. Microservices tend to support good enterprise patterns like CQRS well, but what they're not is an excuse to build lots of little islands of data that fundamentally are part of a bigger enterprise data model, but are not cohesive and are overly coupled. So the litmus test is the one you read here, right? If you ask who owns the data on your project, and the answer is everybody, or your project is in a lot of trouble. Because successful projects, and I'll keep repeating this, all the successful projects I've ever seen are focused on data and the operations on data, and they follow the lessons that you get from data, from domain-driven design. So the idea of a microservice is that each microservice owns its own domain, which is a good thing. And that domain may be represented by more than one or more deployed services, each containing one or more operations. That's cool. Where domains interact, and again, we'll talk about domain interactions and domain-driven design in future videos, you really need to have a team that owns that interaction, the canonical models that go with it, and more importantly, enforces the semantics by using the facade adapter and other good guardian patterns in the APIs over the data. And it's not uncommon to have a domain model that has a lot of littler domains in it, but that there are key identifiers, and a famous one, of course, is customer ID or client ID, that you need across multiple domains because each domain has a separate concern about that. But the authoritative source for client ID and what other information about client that systems hang on to should be very carefully managed to make sure that you don't end up in a situation where you are wholesale replicating or trying to synchronize against data stores. Synchronizing data is hugely painful. So is incremental copies, because you induce gaps where the authoritative data source has a change and the data sources that rely upon it don't ever know about the change for some period of time. And there are eventing things and things like that, and people get very creative about eventing and replication and other strategies, catch-up strategies. But fundamentally, all of these things are a less than optimal solution to that. And there's a law called Siegel's Law that was coined somewhere around 1900-ish. And that is the two watches law. And of all of the different things that are concerns that show up in the videos that I do about enterprise architecture, this is the one that I keep coming back to, because if you have a scenario where system A is the owner of everything you ever wanted to know about client that you were afraid to ask, and system B that not only knows about client ID and knows how to asks System A about information as it needs it, but in fact ends up having a copy or a mutation of the client entity over there, what you've done is you've created a synchronization or replication problem, and you now have two watches, and it's difficult to know what time it is. So, single sources of truth for each of the entities is critical. Even if the data is agglomerated from multiple sources, you need master data management. In other words, you need to know where the data comes from in its lineage. And we have a nice slide for that coming up. And there is no excuse for any kind of persistent data in your system, whether it's unstructured, semi-structured, relational, NoSQL, doesn't matter, for not being under some sort of governance umbrella, right? The mechanism by which we store data or the tools we use to store and manipulate data are important, but the river that runs through that is data governance and master data management. And so data consistency should be something that is an enterprise level concern. And I'm not advocating that we have a top-down, very prescriptive methodology for that. I'm saying that as programs are developed in the enterprise, the data architects and application architects should come together and say, look, we're going to have these new data from these new sources. Does anybody have any data that smells or feels like that? If so, let's see if we can get to a single source of truth by working together. Because a truism is that once things are in the cloud and are easier to integrate, the business will find value in integrating them. And if we have two programs in the same enterprise that fundamentally have a different viewpoint on something as basic as client, we're going to have integration problems. And if we have teams that operate in silos in different programs, and there's no coordination about core identifiers, in other words, the ID representatives of, the idempotent substantiation of entities that really don't belong to any one program, they're concerns for the entire enterprise, we're going to have problems. So, this is an agglomeration, right? You have a single source of truth database or data warehouse, doesn't matter. Doesn't matter how you do it. But, typically these systems work by getting data from all different sources, putting it through some sort of pipeline, and that pipeline does some sort of steps to conform to a canonical model. And a lot of times you end up with something that is a union across systems, which is to say the core concept for, say, client has a certain set of shared fields that are semantically equivalent across all your data sources, but then you may have selective extensions that are only present in source 2 and different ones that are only present in source 4, and that's okay, right? It's still a single source of truth, and we want our consumers to consume the single source of truth. So if I have program A and program B, and they both need to know about client, and they need some basic data about the client, then they should get them from the same place, and they should use the same identifiers so that globally at the enterprise level, we can have an identifier or a set of identifiers that absolutely positively identifies a client. And enterprises should always be on the lookout for opportunities to use an external authority as the source of truth for identity. For example, if clients are companies, corporations, right, then the best source of truth that provides a idempotent identifier is Dun & Bradstreet or somebody like them, if we have a need to know about countries and jurisdictions, the good people at the United Nations through the International Standards Organization have distinctive country and jurisdiction codes. And you can change the labels on those codes to suit your business need. But fundamentally, if you and I agree that when we talk about a country and we're going to use, say, the ISO 3 code, and you get USA, you and I agree that that's the United States of America, irrespective of whatever other metadata hierarchies or additional uh, shaping of that in our system, so that when our systems interoperate, we pass via the lowest common denominator. We agree that the country field or the jurisdiction field will always be an ISO code, and it's maintained by an outside source that's authoritative. And the same with Dun & Bradstreet, and the same with the International Postal Convention for address data, and so on and so forth, right? Every time you have an opportunity to have an authoritative external data source as one of the inputs to your single source of truth, and you use those identifiers, the more useful your system will be, because the more integratable it will be. And if you need to have an entity representation with a different semantic meaning, then the worst case is those universal identifiers will act as system glue. So you and I might see client hierarchies differently in each of our programs, but fundamentally when we ask, well, what is this node? And we get a Dun & Bradstreet number back, you and I have the same semantic understanding, even if our hierarchies or other relationships are different in our systems. So one of the areas that tends to molder very quickly are shop standards for data and data process and tooling and things like that. And one of the truisms are that top down sort of, there's some ivory tower people and they're up in corporate and they have nice offices and they, put out little polemics every once in a while. And they write wiki pages or worse, PDFs that no one reads because they're not relevant, produces terrible results, right? And so the strategy that works in the enterprise is that all the data owners and all the different programs and their architects and their business people and their data experts get together and agree on what the governance should be. And for every piece of governance, for every rule or set of rules that you write, for example, Microsoft SQL Server standards, there should be a reason, right? And if your standard is so prescriptive that you're specifying something as dumb as spaces after commas, when modern diffing tools are capable of ignoring white space, then you've probably gone too far. So governance should focus on a SMART result, SMART being the acronym, right, for specific, measurable, actionable, right? And so on. And I've got lots of videos on SMART you can go watch. And so you have to ask, when somebody proposes a shop standard or a governance thing, is it SMART? And the second question you should ask is, can the tooling deal with this? Can we just ignore it and let the tooling do it before we make people, I've seen a Microsoft SQL Server coding guide that was over 100 pages long. There's not a dev on planet Earth who's going to read that. And so if instead we say, there is a shop standard, and it turns out that our linting tools and our editors and things just enforce that on the fly. And that when you run the linter, if you get no complaints, you've probably written compliant SQL code, for example, then that's great. If there's some sort of a manual checklist or something, that's less great. And so governance without automation is a burden, not a benefit. Evergreen is a core concept in the enterprise database universe. It means evolutionary database design. It means that we can be forward and backward compatible. It means that we have taken the time and trouble to make, columns and fields be representable across our platform, irrespective of the database engine or the programming language or the query language, that, we agree on some fundamentals, right? Strings, integers, decimalized numbers, and so forth. And the test of being evergreen is you have the ability to roll schema changes forward without impacting the running code, which means you no longer have to synchronize your code releases with your data releases, because your database can be on it, or databases, or NoSQL databases, or file storage, or whatever, can be on a different cadence than your code. And it may be convenient to align the release of those two things. But if you have a hard dependency between those two things, you're less evergreen and hence less agile and adaptive than you could be. And, seeding is an important part of that that's often overlooked, right? If we're going to fill the data from somewhere, where should it come from? It should come from the single source of truth, and there should be a process for updating that, and that process should be non-breaking. In other words, we should be able to deprecate data elements without deleting them, and so that old data that still refers to it remains unbroken. If you have to roll a database change and then run a script to fix up a bunch of the data, then, that's probably a lot less good than if you're able to make sane choices without doing a process called backfilling, where not only do you have to change or update the data schema, but you have to write a bunch of code to move data around and fill in fields that are currently null and things like that, right? In a perfect evergreen universe, when you make schema changes, they're forward and backward compatible, and the systems that need the data populate the data, and the systems that don't need the data ignore the data, and the future systems that need the data, if they don't find them, have a sane result. And so keep up with the state of the art. And there is a really good book about evergreen and evolutionary database design from the amazing Martin Fowler, Addison Wesley series called Refactoring Databases. It's a little old, but almost everything that's in there is absolutely applicable to your modern life, and most things follow the Pareto rule, right? So if you followed kind of 80% of their examples and best practices, you're probably going to be in a pretty good place. So the other thing is that data policies, procedures, and awareness, and the skills that data operators and developers and QAs and the business need don't stand still. You're either learning or your systems are becoming irrelevant in front of you. And so times change, and we must change with the times. My name's Stuart, and I do architecture and data in the cloud.